Alrighty, in this video, I'm going to tell you about why I quit my dream engineering job at Ford Motor Company to do YouTube full time, whether I regret it or not, and my future plans for me in this channel. Before we get into all of that though, I need to give you some context. So I'm going to take you through my entire journey of how I became an engineer starting from school, going all the way through university to how I ended up getting my dream job to what exactly it is that I do now. I'm also announcing the winner of the 120-piece Kincrome portable toolkit giveaway, and if you don't win that, I'm also giving away another one, so make sure you stay tuned for details on how to win. Let's start from the start. So from a young age, I've always loved designing and building things. I was that kid that was obsessed with Lego and Meccano. I was really lucky to have parents that fostered me to do this and encouraged me to continually make things. From Lego, we graduated to billy carts, go-karts, model trains, RC cars, bike jumps that turn into large civil construction projects, the list goes on. I was sent to a good school with a really good design and technology department, and I didn't know it at the time, but my teacher Foster would be a key part to shaping my career trajectory. I remember building a chopper push bike in year 9. I was watching a heap of American Chopper at the time, and it inspired me to build a bike with a super long wheelbase and a curved top tube just like I'd seen on TV. To do this project, I learned to weld and to use CAD, which is something I really enjoyed, and this was at the age of 14, which reflecting on it now means that I've been on some sort of CAD software package for the last 20 years, which is actually a pretty crazy thought. The next year we partnered up to build a scale Bugatti. This project was super involved, designing steering components, making a chassis out of steel. I did the underbody work, which was a real challenge for me at the time. My mate Matt did the bodywork, and I remember him making some remark about how out of square everything was. I guess at 15 years of age, I hadn't quite grasped the concept of using jigs and welds warping, but the project turned out pretty cool anyway. We actually still have this Bugatti, and all it needs to run and drive is a keyway on the axle, and we've always said we're going to do it for our kids. Maybe one day we'll bring it to the channel. My final year in school was a tough one. There was obviously a lot of pressure to do well and get a good grade, which would give you a lot of options. The problem for me was that design and technology was the only subject that I really cared about, and it was marked down or normalized, which meant that it would likely not contribute greatly to my final year score. This is something that really annoyed me about school actually. Generally, engineers, scientists, and entrepreneurs are the people who innovate and better the quality of human life. However, taking this path in life was not really encouraged by the education system or my school at the time. Luckily for me though, I had a great teacher, Foster, and he asked me what I wanted to do when I left school. Be on the tools or design things. And I said design things like cars, planes, boats, and trains. I was absolutely obsessed. As much as I like being on the tools, design is where my heart was because it was more of a challenge for me, and it gave me a creative outlet. Based on this conversation, I buckled down for my final year at school, and while the majority of my focus was building a sick air hockey table, which we'll get to in a second, I got the grades I needed in English, maths, and physics to get me into engineering, and I got the perfect marks and ducks in my design class, which is really what I cared about at the time. As I said, I made this air hockey table, and I still look at this air hockey table all the time to remind myself that at a point in time, I could work with wood as well. To get these compound curves done out of wood was actually no easy feat, and I'm super proud for doing a good job at the time. And it's awesome to look back at it and be proud of it. Another thing that I did in school, which I would highly recommend to anyone who's interested in design or engineering, was the energy breakthrough. It was a co-curricular activity where you designed and built a hybrid recumbent trike, which was powered by both pedal and an electric motor. Initially, we started with lead acid batteries, but I'll never forget the first year we had lithium batteries. Our trike was significantly lighter and more agile than it was before. We ended up breaking the track speed limit on our qualifying lap at 80-something kilometers an hour, which I can tell you from memory is extremely fast in a recumbent trike. And we had to start from the back of the grid, but given it was a 24-hour race, position didn't really matter, and we ended up taking the win. I learned so much about making designs robust as I had to survive 24 hours of torture from this project, and I highly recommend it. The formative years of school for me felt like industrial design or product design, which is primarily about how the product looks and how it feels. Compared to design engineering, which is more about how the product works and how to manufacture it. So that brings us to the end of school, and I finished school and I had my heart set on engineering, but I didn't quite know which kind of engineering at this point. I started studying a Bachelor of Science at the University of Melbourne, which was quite general, and it gave me a heap of time to figure out which engineering stream I actually wanted to study. It was between civil, electrical, mechatronic and mechanical. I remember this clear as day. In my first university physics class, my lecturer, Roger, asked, "Can all the people who want to study civil engineering please put their hands up?" About a quarter of the class did so, and he proceeded to say, 1, 2, 4, that's the ratio of concrete. That's all you need to know for your degree, and you can leave now. And honestly, as funny as it was, that's kind of how I felt about civil for the next few years. Things that moved just interested me more. I found some of the subjects in my undergrad super challenging, especially the engineering maths, which personally I don't think is super relevant unless you end up in a research-based role. It actually almost felt like some sort of sick and twisted, never-ending aptitude test, which teaches you to learn quickly and think critically. Hopefully some of the engineers out there can sympathise with me. If you're studying engineering, hang in there. I reckon I've used about 5% of that math applied practically doing design engineering. While we're on subjects I hated, I absolutely hated digital system designs. It never sat well with me. I found it really hard to visualize all the ones and the zeros compared to doing a force balance or something visual on the mech eng side. I scraped by with what I needed to get though, and when it came to what I like to think are the proper engineering subjects, like engineering mechanics and engineering design, I did well and I really enjoyed them. By the third and the final year of our bachelor degree, I had made up my mind that mechanical engineering was my preference, and we finally got to do some practical work in the design subjects. Up to this point, it had pretty much been theory-based work with the exception of some labs. We had a challenge against all our classmates in third year, which was to transport a baseball to a bucket using a robot, then build a mechanism which would actually climb up the rope, which would be triggered by the baseball when the robot dropped it in. I absolutely love this challenge, and it combined a heap of skills that we'd learnt so far. Needless to say, I got really into it. We had a crane robot that would raise the ball on the way to the bucket, which used sensors to find the bucket. And after a couple of long weekends in the shed, we came up with a mechanism powered by a gas strut that would lift itself and the ball up the rope. Quite chuffed with ourselves and our design, we managed to win against all of our engineering cohort. I actually managed to snag the design prize that year as well, which was given to the student with the best design grade for the whole year. That wrapped up my undergrad. I didn't get the highest grades across the board, but I did have a lot of fun, and I was glad I had honed in on the engineering discipline that I liked. Doing a 3-year undergrad and a 2-year master's took a year longer than a typical 4-year engineering degree, but the advantage was that I had time to choose the engineering stream that I liked. And I would recommend this for anyone who is on the fence between streams. Also, you come out of masters with a master's, which sounds pretty fancy, and it can help you land jobs overseas if that's what you're interested in. Cue talking about the masters. I found the masters at Melbourne Uni really hard. The University of Melbourne is considered to be one of the best engineering schools in the country, which is partly due to the amount of research done there, which meant all the subjects were based heavily on theory, and they all seem to have big hurdle exams. A hurdle exam, for those of you who don't know, is where you have to get 50% on the exam to pass, which means you need to know the coursework and the content really well and not to crumble under pressure on the exam days. I basically deleted 2 years of my life to pass a master's and did nothing else apart from uni to make sure I passed with good grades. Masters though is where university started getting really good for me. I found subjects like engineering materials, fluid dynamics, thermodynamics, mechanical design, mechanical dynamics fascinating. And to me, they are what forms the basis of mechanical engineering. Project-based work is what I was most engaged with though. We designed this gearbox, which was for a plastic mixer. This is a scale model and I keep it on my desk to remind myself of what I learnt. The gear calculations are the hard part of this project, and for any engineers in the room, you'll know there's quite a lot to them. But we got to design this gearbox from scratch, which was an awesome project. And we were 3D printing and CNC laser cutting to make this in our 4th year of uni, which was awesome. And it was early days in the 3D print game where we had to level the bed and about 50% of the prints failed. Nothing compared to the automated workhorses we have nowadays. Our team managed to score the best grades across all of the design subjects in 4th year, and I walked away with the design prize again, which was a nice little cash injection into my beer fund at the time. For my final year project, I did Formula SAE, which is basically where you design and build a race car from scratch to compete against the other unis. This was by far the most valuable thing I did at university to help me with my current trajectory. Ours was a steel space frame, which I tied together with a few others over a number of weeks. I remember welding in 8-hour shifts through the night to get this done on time. It was honestly a wild timeline looking back at it. Designing, building and testing a race car from scratch in less than 12 months. The car was powered by a CBR 600 and we had made all of the suspension components from scratch, including the A-arms and the outboard assemblies. One of the most valuable things that I got to do at the time was a machining course at TAFE over 2 years, and I'd learned how to make parts on the 5-axis Mazak Integrex. And here's a stub axle I made during my final year, which is probably not something that I could do now because I haven't touched a CNC machine in over a decade, but learning how to design parts for machining was absolutely invaluable to me. And it's something that I still remember to this day. How we would clamp the part, what tool would be used to remove the material, could we achieve the tolerance specified in those pesky engineering drawings, adding radii to certain bits to ensure that we could actually machine it. It was awesome, it really was. Another thing that I learned from working on that project was working with composites. We actually designed and built a whole aero package in carbon fiber using a mix of prepreg and autoclave and resin infusion and a vacuum pump, which was such a valuable skill to learn. I've actually often thought about doing some composite projects on the channel, but they are messy and I do prefer working with metal. During that year, we ended up placing first in all the driving events and second overall against over 20 universities nationwide. But the results are irrelevant. It's all about the learning. And if you're an engineering student and you're on the fence about doing this project, I promise you that you're going to learn a lot, probably the most you'll ever learn at university, but be prepared to put in some hours. I can't remember doing anything else apart from race car that year. And that's about all I want to tell you on uni. Let me tell you about how I got my dream engineering job at Ford. So during your final year, you apply for graduate jobs, and the only one that I applied for that year was Ford Motor Company, which would result in me working as a development engineer on the Ranger and the Everest programs. I didn't get the graduate job. I was so disappointed. I graduated with, a distinction average and got high distinctions in all of the subjects that I cared about, which was most of them, to be fair, apart from stuff like control systems. And I thought that would be enough to get me through, but it wasn't. And yeah, I genuinely was really shattered. I didn't bother applying for any other jobs as nothing else interested me. I actually planned to take a gap year and just go ride my mountain bike in Canada. By a sheer stroke of luck at the Formula SAE event, I happened to be talking about the Formula SAE car to a group of people who I didn't know at the time, but they were actually Ford engineers looking to hire. And needless to say, my plans to take a gap year were ruined, and I was hired more or less on the spot as a powertrain development engineer in powertrain at the proving grounds out the back of the Yuyangs. Powertrain development was by far the most interesting department at Ford for me. It was applied university at its finest. I had to model the temperature and pressure profiles through various exhausts to enable the after-treatment calibration, which was awesome and super, super technical work. I spent a lot of time on the dyno and the environmental cells that year. All of those MATLAB and Simulink skills I learned at uni were really put to the test, which was actually a super pleasant surprise. It also involved a lot of driving and testing, which I really enjoyed. I remember my first week at work, I got into the car with an older employee who took me to check the fences in a pre-production XR6 Sprint on a Friday afternoon. And for those of you who don't know, the proving ground essentially has a NASCAR-like track, and I probably shouldn't say the speeds we got up to even, a decade on, but that's where my love of Barras was born, and that car was an absolute weapon. I can attest to that. I started in 2016, which was the last year of manufacturing cars in Australia, and it was awesome to see the production lines and the way everything worked. So while I was working for powertrain development, I applied for the graduate program again. And actually I got through the first round this time, which was a surprise to me because my grades hadn't changed at all. I actually managed to get a graduate position, which meant I would rotate around the company and get to see all the other departments as well, and get a heap of formal training for the general corporate world. So I didn't initially get my dream job, but after a few years of persistence, I got there in the end. If you're experiencing something similar, I'd urge you not to give up and try and find a way. And I'm hopeful for you because from my experience, in the end, it was all worth it. If you're a young engineer, I would recommend trying to get on a structured program like this. If nothing else, you'll end up with a great group of mates working at the same company around the same age, which was an absolute hoot. So my first graduate rotation was as a design engineer on fuel systems. I worked on fuel lines for an overseas Everest and Ranger program, and design engineering at a big corporate wasn't exactly what I expected, and let me explain why. After a lifetime of working on projects with essentially near full creative control, I found myself working on a little tiny part of the car, which is the way it works in big companies, and for good reason as well, to maintain efficiency, right? But it wasn't what I expected. I did, however, learn so much that year working with suppliers and understanding all the processes that were put in place to ensure that production never stops. I then ended up in a program management role for a number of years where the work was more email-based rather than engineering, but it was fascinating to understand the process behind the inception of a new vehicle, which was the next-gen Ranger at the time. I got to work closely with the chief engineers who, in my opinion, have one of the best jobs at the company as they get a whole lot of control and have to balance everything from, appearance, design, budgets, headcount, manufacturing, marketing. But the problem is to get into a role like this, you probably need to work at the company for over 20 years unless you're, one of the chosen golden children. And they were generally all extremely smart and motivated people, and I learned a lot from them, especially their business acumen and their methods of questioning to obtain the right information. One of them, who I worked with reasonably closely, had even designed the crank on the Barra 20 years prior, which I thought was awesome, as I've always aspired to technically competent leaders. I then spent a number of years managing complexity in programs, and I found this pretty interesting. Last year, Ford globally sold 380,000 Rangers out of 5 different plants. This is according to ChatGPT, by the way. I'm not giving away any company secrets. And it is honestly astounding how much variance there is between country to country on a Ranger due to things like emissions, customer wants, safety regulations, and different suppliers, and there are other reasons as well. For example, if a certain country really liked a red trim, then they would get that, but the red trim wouldn't be supplied to a country like Australia who didn't like the red trim. And as a result, you'd get more parts in the plant, which is ultimately harder to manage. There's also a lot of variance in the emissions regulations from country to country, which means the powertrains vary a heap. And it's a similar story with safety content as well. What this creates is a lot of complexity in global vehicles, and it was pretty engaging trying to come up with strategies to minimize the number of parts and save costs. I'll give you an example just so you understand exactly what I'm talking about. Just say we had 5 headliners in the plant at a 20% take rate on 100,000 vehicles. We would have 20,000 of each variant. But what if, after some clever engineering, we could reduce the number of variants to 2, meaning that we'd have 50,000 of each variant? What that means is we've got more volume for a particular variant, which means that we could actually lower the piece price. There'd also be potentially less tooling to deal with when it comes to the next refurb, and less headliner variants on the production line, meaning there would be more space and less confusion in the factory. So I did find this part of the work really engaging. A highlight for me from my time in program management was going over to visit the South African Ranger manufacturing plant for a pre-production build. Seeing the scale of the plant was unreal, and I really geek out on manufacturing, as you can probably tell from this video. Seeing the raw sheet metal panels come in, get welded together with robots until they were completed cabs, then they would get painted, put on a chassis and assembled until eventually it resembled a Ranger, which is what I'd been working on behind a desk in Australia for the past 5 years, and it was absolutely mind-blowing to me. It gave me a real appreciation for the scale of global vehicle manufacturing. I spent 8 years at Ford, and I'm so glad I did. When you think about it, a car is probably the most complex consumer product that you can buy, and I really got some invaluable experience when it comes to mass manufacturing, especially seeing how a 100-year-old profitable automaker works. I also learned a lot of soft skills there as well, which are really important. Things like dealing with people in a corporate environment, and also basic things like not hitting reply all on an email and looking like a technology nuffy. Also, I was really passionate about engineering the Ranger and Everest, which was basically all done in Australia. Say what you want about them, but the Ranger is the best-selling 4x4 in Australia and has been for some time, and super relevant to our market. My dad drives one, my brother drives one, I drive one, all of my mates drive them. And it's super engaging going to work and working on a product that was so relevant to our market. During my last few years at Ford, COVID hit, and I was in Victoria in the lockdowns, which were just absolutely terrible for 2 years. Before lockdown, I spent a huge portion of my time riding bikes and motorbikes and being outdoors, which was something I was missing dearly. So I was looking for something else to do. And I was sitting at home, bored, twiddling my thumbs. And the only natural cure for boredom was to get a super expensive project car, which is how Barra 45 started, which you've probably seen on my channel if you've seen it before. I'd seen a half-built one at LCS 4x4, and I decided I wanted in because there was a heap of fabrication and design work involved as well, which is really what I wanted to do. I worked on it pretty much every single night and weekend for the next year or 18 months, filming videos and uploading them as well, which is really how this YouTube channel started. It went on for a few years and my channel grew at a reasonable rate. I had started to work with brands who were offering me products and eventually money to make content. And this was when I decided to leave Ford, which was a huge risk for me at the time because I genuinely liked working there. So I was pretty sad to go, to be honest. I still really miss the people that I worked with as they made it super, super enjoyable. But it was a sliding doors moment for me. I knew at the time that if I didn't give going out on my own a crack, I would always regret it. On the other hand though, it was a massive risk as I have bills and a mortgage to pay and a lifestyle to fund as well. So do I regret leaving my engineering job for YouTube? Absolutely not, but I do miss it, or certain parts of it anyway. The people I worked with were honestly fantastic, and it's been a huge step change to going from working in an office every day to working for myself. It can get lonely, but I do have employees and interns. Actually, speaking of, if you're a 3rd or 4th year mechanical engineering student at Melbourne or RMIT, hit me up. I can take you on for an internship or a final year project. Before we get onto me going full-time YouTube though, I'm going to announce the winner of the toolkit giveaway from the Moto Rack video. So congrats to David Lodge 4482, who suggested adding a jerry can holder as well as potentially using the rack as a recovery point. David put in the work with this comment while he was procrastinating at uni and went through the math to prove that under straight tension alone, it would never fail. However, during a 30-degree downward pull, the bending stress would be more than the yield stress, hence the hitch receiver would bend. I love this comment, David, and you, my friend, have earned yourself a toolkit. Send me a message and we'll get it sent out to you ASAP. This is probably the first time procrastinating studying at uni has actually paid off for anyone, so congratulations. So for 2024, I did full-time YouTube. I took on a little bit of paid engineering work as well, worked on bike rack development, and I worked on some LCS products, and generally I had a pretty fun year. Last year, I released a heap of different content, from wheeling and trips to 4x4 builds to creative projects like the dirt bike canopy, and to more engineering-based projects like the bike rack. What I learned from all of that is that engineering and design really is where my heart is. While I love going on trips with everyone, I enjoy making videos about designing and engineering and building things much, much more. So this year, the focus of my channel is shifting towards that. Engineering and product development is what I'm really passionate about, and I'm hoping you guys are excited to follow along on the journey with me. Let me explain how I'm going to do it and what will be changing on the channel going forward. I'm not saying that I won't do any 4x4 content anymore. We're still going to work on George's build, which is still moving along. And I'm looking forward to getting that thing driving actually. And on that, I'll still be using my car, Barra 45, which is due for a major refresh and overhaul at some point, as it's seen some use and abuse now and it is looking pretty tired. When the new build is finished, then we'll have to go out and test it as well. So hopefully we'll go on a few trips with both the builds together. Now trips are great because you can go out and film for a day and get an episode out of it. Really, really good bang for buck when you're creating content, if you don't end up breaking anything, that is, which can be costly obviously. This is not the case for engineering and build content. Some examples that come to mind for me is the dirt bike canopy, which took me 6 weeks to design, build, film and edit. George's 4-link again took 6 weeks to do all of the above. And then more recently, the bike rack video took us 2 years. And the Moto Rack video is probably taking me 6 months. And you can probably see the common theme here. All of these engineering and design videos take a lot of time. And for me going forward, I will be putting out less videos, but they will be a high quality and they will generally revolve around designing, building, and testing things. I'm roughly going to shoot for 1 video a month, which will enable me to keep the quality high on both the video and the project, which is my priority. I'm also taking on external engineering and design work as well, which I think will be pretty good channel content. As a registered mechanical engineer with 10 years of experience, there's a huge range of work that I can do, from CAD drawing, load calculations, finite element analysis, 3D scanning, 3D printing, and general design work. I can manufacture prototypes quickly because I have what I need at home. Actually, speaking of that, I'm about to do a huge shed upgrade with some pretty flash machines that are going to upgrade my capability at home massively. And I'm going to film that all on the channel, and that will be the next video that you see. My ideal sort of work is product development, where you come to me with an idea and I could take it through to being a mass manufactured product. But there's a heap of other work that I do and enjoy doing, like making canopy fit outs, inspected a hydrogen truck the other day, a heap of FEA for various people. I just did a disc brake adapter for Daniel Kistler, and I'm working with Jacko to make some stronger parts for his Polaris racing buggy. An example of an engineering job I'm going to film and put on the channel is the 3D printed center console for Bryce from Off-Road Escapes for his VDJ swapped 105 series with a chop. It's actually a really awesome car and he's done a really, really good job with it. And we're going to finalize the center console in the next few months, and I'll show you how we did it. I can't show you everything that I work on a day-to-day basis, as there may be sensitive information in there, or there's just some stuff that I've already done, like a canopy fit out, but I will show you select paid jobs if my clients are happy for me to as well. Developing my own products. This is the thing that excites me the most. While I built Barra 45, Laurie and I developed a heap of 40 series products for the 4080 builds, which was awesome. We set up a website, organized the manufacture of the products like roof consoles, speaker boxes, floor pan kits. This was really my first foray into selling our own products. A lot of the time, these products are relatively simple. They're just coming from the laser cutter. They need, a minimal amount of conversion. But I think now we're up to 50 listed products on our website. While all of this was happening last year, Richie and I had been working on our first bike rack as well for Doom Macari Systems. For those of you who don't know me well, I'm an absolute two-wheel tragic. I've grown up on bikes, which is a story for another day. Richie had refined the crank holder retention method for the bike rack, and after 2 years of deliberating and figuring out how to make it perfect, we finally did. And we were able to release the first Doom Macari Systems bike rack, the adventure rack and the touring rack. This is significantly more complicated than the laser cut products that I sell for 40 series because it needs multiple stages of manufacture, zinc coating, powder coating, a heap of source components from various suppliers, and it does feel more like my days at Ford, a proper engineered product, only it's not quite as complicated as a car. But to my earlier point, we do have full creative control and are managing many more parts than I would have been if I was working for a big company. The next big project we're working on is the Moto Rack. There's an in-depth video on the engineering process on my channel, and I think this is the model going forward, showing how we develop products. We've got nothing to hide, and I think it makes for good YouTube content as well. It's certainly different. I haven't seen too much of it out there. Maybe you guys have. There doesn't seem to be too much applied product development. Everyone seems to keep it behind closed doors. Both of us have a few big ideas in this bike carrier space that we haven't seen before, and it feels like we could shake it up a bit if we managed to execute them right. Some of them we would even potentially consider patenting, which would be super exciting to do. Imagine if one of our bike carriers, for example, was to make the difference between someone going for a regular weekly ride or not. How cool would that be? So, as you can probably tell from this video, I'm super inspired to be an entrepreneur. I want to design, develop, manufacture, and sell my own products. It feels like now, in my mid-30s, I'm well placed to have a proper go at it, after learning a heap of skills and getting a lot of real-world experience as well. I'm still going to be doing passion-based projects on YouTube as well, and they won't all necessarily be 4x4 related. I want to do a few bikes, and once George's build is finished, I'll get my garage space back, and I'll probably get another project car. So to recap everything, we've got more engineering, more product development, more passion-based projects, and I'm excited to bring you all along for the ride. As you can probably tell from this video, I have a lifelong obsession with designing, building, and creating things. To this day, I'm still just following my passion. Maybe I can even help to inspire the next generation of engineers along the way, which would be pretty cool. Lastly, if you want to win this 120-piece Kincrome portable toolkit, give this video a like and leave a comment below relating to any aspect of this video or potentially what sort of engineering-based videos you'd like to see from me, and I'll choose my favorite comment and announce it in the next video on this channel. Thanks for watching, everyone, and I hope you enjoyed this video. It feels like a real trip down memory lane for me. If you'd like to see more design, engineering, and making content, make sure you subscribe to the channel. Thank you.